I have to get in there. Sorry, but I have to get in.
That was incredibly graceful.
Oh, here's how I'll do
I
that.
didn't feel you were welcome to come here.
Oh, is that all right?
Just don't step on the,
Just mind the earth.
mind the earth.
Careful.
I know they said this.
Mind the cords. Mind the gap.
I know I'm going to break something.
We don't need to make it flatter than it already is.
Oh, no. There we go.
Thank you so much.
Well, welcome to All Space Considered, everybody. I'm Dr. David Reitzel. I'm muted. Check, check.
Guy.
No, I
Should we all
wasn't.
check?
Now I'm unmuted. Switch didn't work. Anyway, welcome to All Space Considered, everybody. I'm Dr. David Reitzel. And with me tonight is Laura Maya Braun, Bill Gruneberg, Ginger Rose Brucker, and Jared Head for our panel. Thank you. All Space Considered is the third Thursday of every month, and we've been pretty darn consistent about this now, which is great. So come on up to the observatory, spend a night here, and see the show in person if you like, to all our YouTube audience that's out there. Tonight is Thursday, December 18th, 2025, and we have a wonderful show for you tonight. We have a special wrapped edition of All Space Considered. We're going to do some space news. We're going to celebrate Chilean astronomy. Jared's going to lead us through an out to launch. We've got some amazing astronomical images. We've got the Mostest, as we've been doing just about every month. And then we'll have our special ASC wrapped segment. That's why my mic is awful. Much better. Our special ASC wrapped 2025 segment. Now, this image that's behind our titles there is actually celebrating the 30th anniversary of the SOHO mission, which is a solar observing heliospheric observatory. Observation, something like that. Anyway, it was a mission that was looking at the sun from space. So it was able to pick up high energy. What you're seeing here, these are, I think, X-rays. And what you're seeing is a whole bunch of images across the years. This dates all the way back to 1995, and you're seeing more than an entire solar cycle. The sun goes through cycles. Every 11 years, it has a maximum. You can see right here in 2025, the sun is bright. It's glowing. That's that last image on the bottom. And if you go back 11 years, it's also bright, but in between it's very dim and dark. And that's the natural solar cycle that's going on. It's the reason we've been having those aurorae. It's the reason we've been having the solar coronal mass ejections that are happening. And of course, the beautiful sunspots and flares and prominences. You need to come up and take a look through our Celestat instrument and take a look at the sun, folks. It's been amazing. Well, to start our show tonight, our science, I want to talk a little bit about an interesting result that the Perseverance rover had on Mars. The rover has a laser as part of its little mass cam up there, but it also has a microphone, something folks don't know about. The microphone was there to listen to the laser as it zapped things on Mars. We wanted to hear it go pop, 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 pop to make sure everything was working right. But it had another effect. It actually was able to pick up the sounds of dust devils as the dust devils flew over. So that happened, but another weird thing happened. It also picked up noises when there were dust storms. So just a big cloud of dust is blowing around there. It picked up other noises, and it heard little snaps, little pops. And they think these are actually electrical discharges. Just like you get if you rub your feet on the ground, you can actually create some static charge and make a little spark. And they were able to link that to it. So there's both discharge within the dust clouds, and there's discharge between the rover and the ground, they think. So this is kind of a cool result. So we'll be quiet here in the theater and listen to it, and we can hear it pop here. So that's the wind. Those snaps. It'll loop around. That was a dust devil blowing over it. And then we should hear a couple of more pops. So, but this was an unexpected result on Mars, to hear snap, crackle, and pop, essentially, on Mars through little electrical discharges. It takes less of a difference in charge to get a spark on Mars because the atmosphere is thinner. So this was unexpected and a pretty cool result from Mars. Another new result that came out was from Japan, where they found sugars essential for biology on Bennu. This is the asteroid Bennu, and the OSIRIS-REx spacecraft went there, smashed into it, grabbed a sample, that's actually material from the asteroid, brought it back to the Earth, and the scientists opened it up, and they were able to remove a little slab of it. In fact, you're seeing some things that look like real structures on there. There's a vertical line and kind of a horizontal line. That's actually platinum that they kind of affixed to it. They glued onto it to give it a little more stable, to stabilize the material. They brought it into a lab, they analyzed it, and it turns out they saw glucose. They also saw a bunch of RNA molecular components. So it has the stuff to make RNA, it has glucose. Glucose is used by those to give cells energy, to create cellulose. So everything life, well, not everything life needs, but a whole bunch of the stuff that life needs is just hanging out on this asteroid. So it looks like the stuff for life is pretty common in the solar system. So a pretty amazing result.
And there may be apparently some reanalysis of some of the Hayabusa samples as well, using these same kind of methods where they diluted some of the material in water in order to find these components. So pretty exciting stuff.
Yeah, super exciting stuff. Another interesting result is a telescope picked up a mysterious glow near the center of the Milky Way. And they were able to see that. This is a picture in visible light. This isn't the glow I'm talking about. It's from this one. This is the Fermi telescope. And it has a gamma ray. It's picking up gamma rays, so very, very high energy light. Well, then when they went and studied it, there's a slight little extra amount of light coming near the galactic center. And when they went and did models of what dark matter would look like when it annihilates. Dark matter, if it hits itself going in very high speeds, it'll annihilate and make a gamma ray. And this was predicted that it should be doing it. And they've even built telescopes to go look for this glow, and they hadn't seen it yet. Well, these researchers did some models and said, what should it look like? They went in and they were able to see a glow that matches what their model is showing at the center of the Milky Way. And they're saying, could this be gamma rays? Could this be gamma rays from dark matter colliding? And they're like, maybe it is. They also say it might be pulsars down there, bright pulsars, but that's tougher to do. You need to kind of, strap it together in a particular way to have the pulsars explain it, whereas the gamma rays, the signal looks like the signal you'd expect. So are we finally detecting a little bit of a signal from dark matter? And you might say, I thought dark matter didn't react with light. Well, it doesn't. This is when it's being annihilated. So when it's being destroyed, it can give off light. But maybe. So this was an exciting result that we're waiting to see if it can be verified. There will be other telescopes coming online in the submillimeter where you can go look at this stuff. You can look at, or I guess this is Cherenkov telescope array. It'll be a gamma ray telescope. This is not submillimeter. That's another one I'm going to talk about. Anyway, so this is going to pick up the glow as well when it's finished, and it should have enough signal to really verify this result, to find out, are we seeing the destruction of the dark matter or not? So very strange. Well, in our first ASC Wrapped section for 2025, Laura May and Bill went out on the floor at Griffith Observatory and you surveyed some museum guides.
That's right.
So yeah, Bill, why don't you tell us a little bit about what you learned?
Well, we learned that a lot of people had different interests, and they were asking, the questions that we get are, about people who are interested in different things. Hugo Ballon murals are going to be art people and so on, and planet symbols might be the same. Planet symbols is actually a very, very common, in my experience, as a museum guide out on the floor.
We should add that these were questions from visitors to Griffith Observatory.
That's exactly
so
right.
These are the questions that everyone, a lot of the people on the floor, not everyone knows this, but if you see someone on the floor with a blue lanyard, many of those people are researchers, graduate students, meteorite collectors, people who have specialized knowledge. And so we wanted to know what exactly the public is asking us when they come through these doors.
Mm-hmm. Yeah. Well, the most common question actually is, where's the bathroom? But we deleted that one from the results.
Downstairs.
Just saying.
Downstairs.
To the moon and
To
hang
moon
a
and
left.
right.
We have a good answer
Yeah.
for her.
But I love that people were asking about the lunar standstills while they were up here. Those are
Mm.
events that we hosted up here for the past about year and a half. We finished our last event, but people wanted to know about them, and they were very interested. And that was our goal, is to bring that to the public. So that was exciting.
The black holes one, I should say, is the most common one we get on our school program. We have this wonderful school program that brings children here in person and online. And that is, they always want, even more so I think than alien life or things like that, they want to know about black holes. Now they want to know about white holes. They have all sorts of questions about cosmology. It's very exciting to them. And unfortunately, we do also, I shouldn't say unfortunately, but we do get more, how should I frame this politely? More questions about the moon landings these days than we used to.
Yeah.
I think some famous influencers said some things online, and and if it makes people interested and ask people here, that's wonderful. We always want to talk to people.
I might have to revive my moon landings. Harder to hoax. It's actually harder to fake it
Yeah.
than just to go, to be honest. I think your hair's running into your mic, but
Oh no, it's right here.
well, we're getting a weird pop from
Okay.
it. From
Yeah,
anyway, so so interesting questions from the public, and come on up and ask the questions to our guides. We love when that happens. So we wanted to report on what was there. Now, Laura May, you spent some time down in Chile a little bit. Wanted to tell us about what's going on down there. Why do we have telescopes there?
Absolutely.
What's the story?
So you might have seen this in the news. In fact, we covered this earlier this year. It really was. It was front page news on the BBC, and because it's a very, very big deal. We had the release of the very first images from the Vera Rubin Observatory in Chile. So this is the Lagoon Nebula. This is a star-forming region in the Sagittarius constellation. Absolutely magnificent image, but also part of some incredible science that's being done there. So I was lucky to visit this observatory. That's it on the left, the Vera Rubin Observatory, while it was still under construction. And you can, again, watch our July episode if you want to hear more about the revolutionary work they will be doing. But it is not the only telescope in Chile, believe it or not. So LSST site, that stands for Vera Rubin. That is also the name of their survey. And very close to it sits another major observatory, that is the Gemini South. It began operations in the year 2000. You can see it has this kind of unique design. If you really see it from the top, it has this kind of burger design where it opens actually in the center to cool down instruments. And it's named after the constellation of Gemini, the twins, because it has a twin on Mauna Kea in Hawaii. In fact, we had mentioned that we might bring up the fact that I think sometimes it's not always obvious. We need telescopes in both the northern and the southern hemisphere. We need to be able to survey the entire sky because parts of the north are not visible in the south and vice versa. And here is its main mirror. So this is an 8.1 meter telescope. Now there's only a couple of telescopes in the world that are bigger than this one in terms of a single mirror, right? The VLT in Chile, which I'll talk about later. The Subaru in Hawaii has an 8.2 primary meter, and actually in Arizona is the largest single mirror. It's the Large Binocular Telescope. There are two of them. They are 8.4 meters. And this is basically as big as we can make these single telescopes, these single mirrors, sorry. They become too difficult to transport, to cast, to support. So anything bigger like the Keck, maybe you might have heard of, or the James Webb Space Telescope up in space, all of these are going to be segmented. So they're little pieces that are stacked together, a bit like honeycomb. So here's an image it shot this year of the interstellar comet 3I Atlas, courtesy of Dr. Bryce Bolin, who was our guest last month, and a few others. And this is the mountain that you can see. Gemini is kind of the one that sticks out the most here on the left. The Vera Rubin is out there on the right. And they all share this mountain called Cerro Pachon, as well as the smaller, lesser known, all the way on the left, that is the SOAR telescope. And it just had first light on a high resolution spectrograph, and it is searching for population 3 stars. So these are the first stars that were ever created in the universe. So very exciting. And again, that site, several telescopes and observatories, but it's one of many, many more. So today there's about 40 international university, public, private observatories that are operating on Chilean soil. And there's currently at least about 115 both professional and amateur observatories in Chile, again in this very narrow band of land. So you might be wondering, well, how did this happen? Some people have, haven't really followed what's been happening there. And it's important to start way, way back because there's a tremendous amount of history of astronomy in Chile. And this starts, of course, with native astronomy, right? There are traces of Chilean, what we might call cosmovision, right? Their vision of how we view the universe and the world around us. And that goes back very far. That goes back about 1000 BCE, the traces we have of that. And there is this beautiful term called the Bennu Maput. And this is a Mapuche term. That is one of the natives, native people there. And it denotes the land above. So they have the land above, the land that is here, and the land below. And the land above is, of course, the celestial world. And there are differences across Chile, across the different native cultures. And of course, many cultures have differences in how they characterize the sky, constellations. And Chilean culture had this very, very particularly interesting way to see the Milky Way that I had never heard about. So this is an image that I shot from the CTIO observatory. And I think it hopefully speaks volumes about the quality of the sky there. This is one exposure. This is about 25 seconds. I edited just a little bit, but it's pretty much a raw image. And as a result, their cosmovision recognizes not just stars in the Milky Way, but also dark constellations. So that is what you are seeing here. So they're made of these dust lanes that you can see in the Milky Way. And many observers, if you've been in a really dark sky, maybe you've seen the band of the Milky Way, you might be familiar with the Coalsack Nebula, this kind of dark region in the Milky Way. And right here, you can see it. It is U2. The bird, not the band. And modern paintings, of course, of some of these dark-shaped constellations. So this is showing us, we've got a baby llama. Llamas are very important in Chile. We've got the mother llama, and it's got little googly eyes. Those are the brightest stars in the southern hemisphere. So those are Alpha Centauri and Beta Centauri. So there's a lot going on in the sky. And their cosmovision also recognizes not just stars and the Milky Way and these dark constellations. Let me see if we've passed this image. There we go. But many who've been to the southern hemisphere, anyone here been to the southern hemisphere? Yeah, a couple of you. You might have seen the incredible small and large Magellanic Clouds. Now these are little satellite galaxies. They're little satellites to our own Milky Way. And the way they see the Milky Way as this beautiful river of the heavens, there's of course a continued water mythology. So they see these Magellanic Clouds as little ponds, or even sometimes as little eyes. So really beautiful mythology. And all of this, of course, this background that laid the foundation for Chile becoming really the mecca of astronomy nowadays. It's estimated that by about 2030, 70% of the world's astronomical infrastructure will be located in Chile, within a patch of desert that's about the size of Oregon. If you can think about it, really a lot of observatories and telescopes. So this is here the Cerro Tololo Inter-American Observatory, CTIO, that I mentioned earlier. And what's important to note also is that this is the result of about 2 centuries of collaborations between Chile and the United States. And later on, other countries also joined in Europe and Brazil. So it really began modern astronomy when, in 1849, the US Navy sent a lieutenant to contribute measurements to an international project that was aiming to calculate Earth's orbit. So he built a very small observatory, trained local people there. So you can see here, this is an engraving from 1872, and this very observatory ended up becoming the National Astronomical Observatory of Chile. And then about a half a century later, representatives from University of California's Lick Observatory, which is located near east of San Jose, and it was built in the 1880s, there's a picture of it there, and they came and they built a second observatory in Chile. And this brings us to a slightly more modern, lesser known, but incredibly important observatory. There's an image of it somewhere in the observatory, in Griffith Observatory. Now this is the Victor Blanco telescope. So this was built in the 70s. It was named after a Puerto Rican astronomer. And for 20 years, this was the largest optical telescope in the entire southern hemisphere. Now it has a twin on Kitt Peak in Arizona. Again, we want to have those both hemispheres covered. It's the Mile telescope over there. Now all of the images and the data it's collected have actually yielded more Nobel-winning discoveries and papers than any other, including the 2011 win on the expansion of the universe. So really amazing science being done there. And all these facilities, the Rubin, the Blanco, Gemini South, they're all operated by Noir Lab. And this is an image it took, so it was shot by its dark energy camera. It's almost mythological. Of course, what you're seeing, so you're seeing a cometary globule in what's called the Gum Nebula, that little galaxy that it looks almost like it's reaching for, is of course much further away in space. But thanks to the survey, their dark energy survey, this year saw the release of something really, really groundbreaking. It was a study suggesting variations in dark energy. So dark energy is this force that drives the accelerating expansion of the universe, and they think that it might actually evolve over time. So it's not static. And this survey looked at over 300 million galaxies. I think they used about 16 million for this. And DCAM, it's also been used to discover new moons around Jupiter. All sorts of science has been done with this. Now, around the time that the Blanco first saw light, so again in the 70s, there was, of course, unfortunately, a coup in Chile that helped install General Augusto Pinochet, and that led to about a pause of about 20 years in the construction of new observatories. Now, the Blanco is, of course, the flagship of CTIO, the Cerro Tololo Inter-American Observatory, but next to it sits a whole host of little observatories, right? Many of them are also managed or co-run with universities in the US and elsewhere. You can see it right there. It's called the Mushroom Farm, affectionately. It's very cute. So many of them are quite small, and they sit next to these huge observatories. So there's about 40 telescopes on Cerro Tololo, and one of which is not discussed enough, is one that just celebrated its 30th anniversary. In fact, that coincides well with SOHO. So this is one of the Gong telescopes. This was the telescope I was most excited to see. I know it's just a little container here. You can see that little telescope there that's peeking out, and there's a little office inside and processing machines. And these are solar telescopes, and they're providing really, really important data on solar activity. So this view will be familiar to all of the solar observers. And hello, yes, some of our audience members who work here. So there were originally 6 of these telescopes. One of them on Mauna Loa in Hawaii, unfortunately, was cut off by some lava. So there are now 5 so that they can do around-the-clock monitoring of our star. And one of those is actually also in California. So it's just a couple hours north of here at Big Bear Lake. Now, eventually, when the dictatorship ended, foreign astronomers were able to return to Chile, and they started negotiating some bilateral agreements to build the next generation of really large telescopes, right? So fast forward to the 1990s, when Europe funded the building of the Very Large Telescope, the VLT, at Paranal, and it is operated by the European Southern Observatory, and it has taken also amazing readings of the sky. They've won 3 Nobel Prizes, and they've given us incredible images like this one. Now, this may look like a little blurry image of 2 dots, but this is the first direct image of an exoplanet. So this is a planet outside of the solar system. This was shot in 2004, by the way, just over 20 years ago. And so you can see that little red dot here. That is our warm planet there. And I think it was actually orbiting a brown dwarf. So a sort of hybrid object between stars and planets. So it is one of the most productive facilities for astronomy, second only to the Hubble Space Telescope in terms of the number of scientific papers that it's produced at visible wavelength. And there's a very important human ingredient that doesn't get mentioned enough that appeared around the same time and was really essential to Chile becoming so important to astronomy. Now, some of you may know, if you know anything about the telescopes in Hawaii, that 15% of the observing time on those telescopes on Mauna Kea goes to the University of Hawaii. So that was agreed in 1968. It's obviously to foster local astronomy. And in the 90s, Chilean astronomers brought in a similar new requirement. So they asked that 10% of observation time had to be reserved for Chilean astronomers. Now, unfortunately, that wasn't really applied until it was enforced when 2 astronomers, so these 2 ladies you can see here, Monica Rubio and Maria Teresa Ruiz, convinced the government to actually do so, to enforce this. And since then, the number of professional Chilean astronomers has become 10 times greater. Just think about it, the past 30 years. So now there are nearly 300 Chilean astronomers, which is pretty remarkable. There's about 800 undergraduate and postgrad students studying astronomy. And this is out of, if you keep in mind, there's about 13,000 astronomers in the entire world, half of which are in the United States. So pretty remarkable that they've managed to do that. Now, another more recent major observatory is ALMA, of course, and that stands for the Atacama Large Millimeter Array, and it started operating in 2013, so it's pretty recent, from the Atacama Desert. It's a radio observatory, so this is why you are seeing dishes instead of those standard mirrors you might be expecting. So radio means that they can observe 24/7, right? They're observing in a different wavelength of light, and they can observe in daylight as well. So it's even able to observe the sun.
Well, one thing, go back to the other image. One thing about these is the reason these are there is that's an incredibly dry place. You might be like, there's snow on the ground. It was really pretty rare to get snow like that, actually, so this is a remarkable picture. But the air is very dry. To be able to pick up stuff in the submillimeter, the water vapor blocks a lot of that energy. So if you get up to the super dry Atacama Desert and you're up at, what is it, at 14, 15,000 feet, it's really, really high up. You're above a lot of the water vapor and you can pick up things. So not only does Chile have a view of the southern hemisphere, it's really dry there. So it's another reason we build them.
Not a very friendly climate for people. But,
No,
you know.
no. In fact, I
It's
think
the unfortunate thing of
don't they make you wear oxygen?
Yeah,
when you're
so
there?
I'll come to
Yeah.
that, but it's designed primarily to observe remarkably faint objects, right throughout the universe. So distant galaxies, planet-forming disks around young stars, and that's what led to create this really iconic image. I mean, you see this everywhere in astronomy. This was the planet-forming disk surrounding a sun-like star, HL Tau. Very, very amazing image. You can really see even those little ridges in there where perhaps planets are forming. And this image, by the way, and the research is quoted in about 1,000 scientific papers in less than a decade. So pretty remarkable. And it also contributed, you might be familiar with these images of the supermassive black holes. One of these is at the center of M87, another galaxy, and our own Milky Way galaxy. So we imaged that central supermassive black hole. So here it's seen outside of the ALMA headquarters. It's pretty great to see this when you're just walking around in the streets. And it has, so ALMA, the entire array, it has about 66 dishes. Some of them are quite different from one another. They're all varying sizes. They're located on the Chajnantor Plateau, and they can be up to 16 kilometers apart for the extended array. That's half of that in miles, probably about 10 miles, something like that.
10.
And because it sits at 16,000 feet, that's more than halfway up Mount Everest, so you can only go up there with oxygen, right? And you also have to pass some health checks. Unfortunately, some people in my group were not able to go up. So my hat goes off to all the people who are working up there, the engineers who are working on those antennas, on those dishes, moving them around. And there's also a lot of really great regulation, by the way, that was brought in to keep workers safe and to make sure, again, there's a number of hours that you can work up there. And you might think, well, this must be the highest observatory in the world. But it's not. In fact, that honor belongs to an observatory that you can actually see from right where I was. So right there, that building, this is the University of Tokyo Atacama Observatory. It sits at 18,500 feet high, right? So it's on Mount Chajnantor, which you can see from the plateau. It's a 6.5 meter optical infrared telescope, and it's now the highest in the world. So one of the advantages being so high up, it means that there's far less moisture in the air, right? As you were mentioning, super, super dry. And because of that, it can actually observe almost the entire range of near-infrared wavelengths, right? We send telescopes out of our atmosphere to be able to observe the entire infrared wavelengths. So it can even observe mid-infrared. So there's no other earthbound telescopes that can actually do this. So all of these terrestrial observatories, they're capable of taking higher resolution shots of space because they've got larger apertures than their space-based counterparts, right? So all of these are going to be used. So Tau, I think, just kind of came online, or they just finished building it, so it's going to be observing the birth of galaxies and the origin of planets.
I'd imagine they also will have a big spectrograph on that. Large spectrographic instruments are difficult to get to space because they're big. So you can do
I have a quick question.
Yeah.
Do people who work up there for a long period of time adapt to that low
I think I don't.
You do.
They do?
I mean, I know
At
that
18,000?
there are native people who are more the
Yeah.
same thing you see in Nepal, right? There are a lot of people who are more adapted.
Yeah, that's true.
You adapt to a certain degree, but there's limitations inevitably of the human body. Come a certain.
And different people can acclimate to it better than others. It's,
Yeah.
it's surprising.
So there are, of course, people who just can't go up, and that's why they make you do these health checks. And so all of this is possible because of this very unique geography. So you can see here, you can note that kind of massive cloud that's really separated here on the eastern side of the Andes over Argentina and Bolivia. And in blue, right here on the right, so that's the coastal range. In yellow, that's the hyper-arid core, and the Andes Mountain and the foothills in green right there. So this creates these 4 magic ingredients that you mentioned that we need for astronomy. We need high altitude, we need extremely low humidity, we need very stable weather, and we need enormous stretches of uninhabited land because that leads to very minimal light pollution, right? So Chile is actually also an analog for Mars. So it's been used for studies on Mars, right? And there's a lot of other projects that are being built. I showed you all these observatories. So there's the GMT, the Giant Magellan Telescope. So this is an artist rendering. So that's going to be one of 3 colossal observatories that are under construction, also in the Atacama Desert. So it's got 7 primary mirrors. They're each measuring about 27 feet in diameter. And they're using 17 metric tons of specialized Japanese glass. And it's going to have 10 times the resolving power of the Hubble Space Telescope. So that one should be completed in about the 2030s. There's, of course, the EELT, that stands for European Extremely Large Telescope, where I think we're reaching the limit in terms of adjectives we can add to how big they can be.
Most biggest telescope.
Most biggest. We should offer Mostest.
Yeah.
But this is going to be a 128-foot main mirror inside a dome that's nearly as tall as the Statue of Liberty, right?
Yeah.
So this one's going to be able to directly image and study the atmospheres of potentially habitable exoplanets, right? Those other planets far away in space. So that's actually coming up. That's going to be completed in 2027 or 2028. So pretty exciting. And you mentioned this one earlier. There's actually a couple of gamma ray observatories that are also in the works. Cherenkov Telescope Array, the CTAO, and that will have a twin on the Spanish island of La Palma. So it will detect Cherenkov radiation, which is a byproduct of the most violent and powerful events in the universe. It's a little bit like our cloud chamber, if you will, out there. So we're detecting byproducts of these very violent happenings in the universe. Now, unfortunately, I do have to mention a lot of this is currently threatened. This is a really big deal in the astronomy community. There is a new power plant that is projected to basically set up shop right next to them. It's going to be located just a few kilometers from the Paranal telescope. That's the VLT, the EELT, and that's being built by a subsidiary of the US power company, AES Corporation, and it would be pretty catastrophic for humanity's access to the skies, right?
Now, why are they building a big power plant out in the middle of nowhere?
I'm guessing it's a convenient location.
Well, it's for the mines.
It's for the
as well.
mines.
It's
That's
for the
right.
mining. There's a huge amount of mining that goes on nearby. In the mining communities, you'll see little scattered lights when you're observing there. They've been getting worse and worse and worse. And as mines get bigger and bigger and bigger, they have more power demands.
Although some of it is apparently green power as well.
Sure.
So it's actually projected to be basically like a little city, and that would blight the skies, equivalent to a little city nearby.
It's the lights they use for mining that are making things bad too. So the glow of the giant pit mines is causing.
It also creates micro vibrations, air turbulence. So many people have spoken out worldwide and tried to convince the Chilean government to appeal, basically to either move this site or something like that. So this is this is happening right now. This is a concern, and so we'll see what happens. I think we all hope that astronomy can continue its worldwide role in diplomacy and creating all these international relationships and cooperation. And of course, if you ever get to visit Chile, it's one of the most remarkable things is you will see that astronomy is absolutely everywhere in Chilean culture. It is something they see their skies as a natural resource that they want to share. There's tours of the night sky. And I should mention, I was able to go there thanks to the National Science Foundation. That budget, unfortunately, has disappeared. So I want to say thank you to my ACAP cohort who allowed me to go see all these majestic sights and share them with everyone.
Yeah.
Yeah.
Well, thanks for that report. Chilean astronomy is,
Thank you.
talk to that later. It's, like you were saying, it's so important for us to have views in the north and the south. We can't see through the Earth up here, so we got to put telescopes down there. But a lot of telescopes had first light, so we're going to unwrap those here tonight. Like you were saying, the Vera Rubin Observatory had a first image. The Carruthers Geocorona Observatory, the 4-meter multi-object spectroscopic telescope, the large aperture telescope, and the visible tuner filter. So let's take a look at just some of the pictures that Vera Rubin took here. Pretty, just gorgeous.
And you can
stuff.
zoom in. You can go online and zoom
Yeah.
in and just see the tiny little details on some of these pictures, faraway galaxies.
The 4-meter multi-object spectrograph telescope, well, we don't have an image from it because it takes spectra, but this is sort of the field of view it can take spectra of all at once. Each of those little dots will be a separate spectra of a different object. It's on the 4.1 meter telescope for astronomy in Paranal in Chile, so very cool instrument.
Yep.
The Carruthers Geocorona Observatory. Bill, did you figure out what that one was all
We'd
about?
never heard about
I know,
this.
we were talking about this the other day. I'd never heard about it, but it actually takes images of Earth from the L1 Lagrange point. So it's back off at L1 looking at Earth, and it can take pictures of the outer glow of the Earth. I hadn't have heard of this mission, so we'll do a little research. We'll come back to you as more stuff comes out. This was one of your favorites.
This was a favorite, of course. This is the visible tunable filter, and this sounds like a mouthful. This is on the Daniel K. Inouye Solar Telescope. This is the largest solar telescope in the world. It's in Hawaii, and it reached this major milestone. So each pixel that you're seeing in this image corresponds to about 6.2 miles, or about 10 kilometers.
That's insane.
I remember at the time we had the image we'd used had a little comparison to the actual continent or the country of the United States, and we're able to resolve now these details on that level on the sun. Pretty amazing. And so what this instrument does, it's able to resolve magnetic fields. It creates these kind of movies of the changing and moving magnetic fields. That's really important, again, for monitoring the sun and being able to, it has the highest possible spatial and temporal resolution, basically, from these images from the DKIST telescope. So really incredible.
The Large Aperture Telescope, it's the one that's using submillimeter that I was confused about earlier. It's going to observe the cosmic microwave background radiation from the ground at the Simons Observatory. And this is its first light image of Mars, believe it or not. That's an image of Mars. So its resolution isn't amazing, but it is taking these in the submillimeter. So very interesting result. We'll wait to see the cosmic microwave background radiation
Exciting.
from it. So, well, Jared,
Yes.
time for a little out to launch. Are you ready?
Time for a little.
Did anything happen?
A few things
This year?
happened. So a little bit of a launch break, if you will. You may have had a launch break on the day that this launch happened, which is Soyuz MS-28, which was launching a 3-person crew to the International Space Station, because this launched on Thanksgiving Day for us here in the United States. So I was up watching it while the cooking was beginning that morning, and Russia and their Roscosmos group was definitely cooking with their Soyuz rocket, getting the crew nice and safe to the International Space Station. Now,
Nice,
it wasn't.
nice, clean-looking launch.
It was a clean-looking launch, but the aftermath of it wasn't so clean. Because it turns out that there may have been some rushing going on at Baikonur, where some safety pins that were supposed to be in place hadn't been put in place because they said, just get it going because we have a lot of officials here for this launch. So we'll skip that. Don't worry, nothing bad could possibly happen. Now, to kind of show you what happened, this is the understructure of this launch pad, Site 31 at the Baikonur Cosmodrome in Kazakhstan. That structure is attached to the bottom of the launch pad, but it can be moved out of the way, and it was rolled out of the way as it is on standard, but it appears that the pins to hold it in place were not put in because of that decision to rush it. So after that, this is where it ended up, which is at the bottom of the launch pad, and typically you don't want your hardware to end up under your rocket, let alone destroyed under your rocket.
But how big is the pin that was
Pins, as far as I saw, they were like a hand size.
okay.
So yeah, and there's like 8 of them that should have been put in place for that. So the most important thing about this, and why I actually said I feel like this is one of my top 5 big launches of the year, is because of the impact of this. Because Site 31, this launch pad, is the only one that Russia has that is capable of doing crewed and cargo flights to the International Space Station. They have no other launch pad capable of this anywhere. So you cannot launch a rocket without this system in place there. So Russia says they're going to get it done by April, but most of us who work in industry, and especially people who have the expertise in Russian aerospace and other things like that, are basically saying a year and a half to 3, maybe even 4 years for this pad to get back online. So right now, they are looking at trying to figure out what we can do to cram as much mass into the current American and Japanese cargo vehicles there. Earlier this year, there was a test done with a SpaceX Cargo Dragon to see if they could add extra fuel tanks to the back of it and provide it as a system to boost the International Space Station's orbit, and it did so successfully. So it looks like they tested that just in time, because the cargo vehicles from Russia are the ones that supply the fuel for the thrusters that maintain the orbit of the International Space Station. So of course something like this would happen exactly when you don't want it to. So here we are. Luckily those things are in place that can allow it to do it. Also, Northrop Grumman's Cygnus XL vehicle is capable of providing orbital reboost capability as well. And Japan has a new cargo vehicle called the HTV-X, and we'll see how that works.
Does the Progress still go up to deliver?
So this is the launch.
This is
the
the
launch site
Progress.
that Progress would use for the International Space Station specifically. They are talking about possibly taking spare parts and moving them to a different launch site somewhere in Russia, but again, they've just it's amazing because one, we actually got this. It took them almost a week to basically admit that this had happened, even though on their live broadcast we saw it immediately after launch. And 2, they just really aren't talking much about it in terms of detail. Hopefully they're talking to NASA about it a bit more than we are, which is reasonable, but it's not a good situation for Russia's space program.
Did you say, do they think they can actually salvage stuff from that last picture we saw?
So that I am unaware of, unfortunately. So, but what I am aware of is that this is a very interesting rocket called the GQ-3, which is being launched by a private company in China called Landspace. And of course, private company in China, take that with whatever grain of salt you want. But they have developed a rocket this rocket called the GQ-3 is basically a Falcon 9 competitor that's flying on methalox. So instead of using kerosene and liquid oxygen, it's using methane and liquid oxygen. But their big thing here is that they were trying to be the 3rd company to successfully land their rocket. So let's see how their first stage booster did coming back. Are we ready to take a look at that beautiful footage from it here? So let's see how their booster on their rocket did here. Okay, engine's lit. It's coming back in. All right, we're looking good here. It's a lot of fire now. So let's take a look. Maybe it got close to the landing pad at least, and we'll see hopefully a little freeze frame of that here. But you can see middle of nowhere, China, so out in the desert, which is better than dropping it near villages like a lot of the Long March ones from the government have been. But yeah, they made it back to the landing pad. It somehow diverted and it hit the side of the landing pad, which admittedly their landing pad wasn't very big. It was maybe 90 feet by 90 feet. But the fact that they have the capability to be able to do that, very interesting, and of course, good luck to them. So we'll see. We'll see if they join the reusable rocket club.
Is this easier to do on land than on water, like SpaceX does?
I think it all kind of depends upon what you want to do. I think a better way to phrase that is it easier to land outbound as opposed to doing a return to launch site kind of flight. And I would argue that it's all about the energy that you're expending to get out there. I would say for this kind of a launch, they were going to low Earth orbit, so it wasn't necessarily a lot of energy expenditure involved in that, say, compared to Falcon 9 that's going to geosynchronous transfer orbit or sending satellites to much higher altitudes, which means you have to burn your first stage for much longer, which means you need to let your first stage sit in deceleration for much longer as well, so you increase the forces on your first stage. But also, I don't want to diminish this as well, because this is extremely hard to do.
SpaceX crashed a whole bunch of boosters.
Yes, they did.
Yeah.
So
And
it's not.
I was just going to say, to emphasize just how hard this is to do, we're just a few days away from the 10th anniversary of SpaceX landing their first ever booster for Flight 20 with the Falcon 9. And it only was just this year, just a month ago, that a competitor finally was able to land a rocket.
Yeah,
So
we'll show that in a second.
Yeah.
So, some of our ASC wrap stats for the biggest blast-offs, there were 314 total launches in 2025 so far. 303 were successful, 11 failed. So that's a 96.5% rate. I don't think I'd strap myself into a booster and take that risk still, but some would. Well, it depends on the safety.
I might
of the
take a
thing.
suborbital flight. It sounds fun. If
Okay.
anybody's watching, I'll take one if you got it. So
Anybody out
Me
there
too.
want to donate?
Yes.
To the, it's all of us or none of us.
yeah,
That's right.
I was going to say, let's
all
do,
of all. We can do a GoFundMe. I
that'll
think.
be.
So I guess it's none of us then.
So come back for our August 2028 show.
So, but Jared, I asked you for your top 5, and you said those other 2 we just saw were 4 and 5. So what was your number 3?
So number
favorite launch?
3, I would actually say, was SpaceX's Starship Flight 10. So before this, they had an absolutely, all of a sudden, huge stumble. Like, they didn't just they didn't hit all the hurdles. They hit their head on all the hurdles after several flights before this. So losing them in flight, blowing up a rocket at their test site, which ended up blowing up their test site. Which, I don't know if any of you are in the rocket business like I am, you typically don't want to blow up your test site. But this was sort of their comeback. It wasn't necessarily like a Game 7 elimination thing. I was talking with somebody and I was like, this is more like in the 5-game series and it's Game 3 and it's 1-1. You know, you still want to win one to get it. But it was just a necessary flight that needed to be successful in order for things to move ahead with the Artemis program and their whole Starship testing program, and they did what they needed to do. Probably the biggest part of this is that the vehicle actually came through re-entry and they were able to get all the data with those tiles that you'll see here, those different colored tiles with different materials. That was the important part because they didn't have data before that for that. So
Those are real images, not CGI.
yeah, so that's
real.
real, in case you're wondering.
Yeah.
And by the way, just to give you an idea, that's the Starship, the actual upper stage, it's about 180 feet long. So it's 60 feet longer than a space shuttle.
Wow.
So if you've ever seen Endeavour, imagine another half of Endeavour attached to that. That's how big the thing
Coming
is.
down, landing there.
It's freaking huge.
So that's pretty amazing. Now, what was your number 2? This wasn't a launch,
but it was a pretty big deal, which is that Firefly Aerospace had a lunar lander called Blue Ghost 1 launched back in January of this year, and it landed in February. And what was so awesome about this is that this is a private company doing their own thing, their own contract work to try to get payloads to the surface of the moon. Several companies had attempted beforehand. Several countries have attempted to land on the moon beforehand and crashed and burned. And then here comes the little, I don't want to say little, but somewhat smaller Firefly Aerospace coming in and successfully landing their Blue Ghost lander on their first attempt.
And this is all real footage as well.
Yeah.
This is not.
It's not
CGI.
AI.
It's not AI. This is real.
And the first 4K footage we've had from a moon landing.
I love
as
seeing
well.
the shadow right here. This is just brilliant.
And I love this
footage.
because you see it kind of wobble because it landed on the side of a crater.
Oh, yeah.
Ooh, so
Kind of spooky.
yeah, it's a little weird. And also the lunar eclipse that we had earlier this year, the total lunar eclipse.
Engineer ops. Y'all select the landing. We're on the
So they actually did take imagery, a time lapse of the lunar eclipse from the surface of the moon. So if you want to jump on Firefly Aerospace's YouTube channel, they have some amazing footage of what they did on the moon
cool.
with this lander.
Now-
A lot of science, which
Yeah.
is cool to see.
Now, what was your number one?
My
What was
number
the number
one-
one launch of the year?
My number one absolutely had to be the New Glenn Flight 2 landing boogaloo, I guess is what I would call it.
Is this the choppy?
So, what's up?
I don't want to spoil.
this isn't. No,
Okay.
this is
No.
New Glenn.
No. This is
Blue Origin.
this is good. So this was the second flight of Blue Origin's New Glenn rocket, and I think this is just a fantastic looking rocket, like a classic rocket. And they say millennials don't like diamonds. Well, these are the diamonds I'm interested in, mock diamonds, baby. But eventually the payload fairing comes off and the booster separates, and Blue Origin's been taking their sweet time in getting things going. But the booster eventually flew back. That's it doing its entry burn. And here it is coming down to do the landing burn on a ship called Jacqueline, named after Jeff Bezos' mom. And as it comes, I guess I would name the ship after my mom too, if I could. So there's the booster. It was really cool because unlike Falcon 9s, which do this hover slam where they go like 0 on the ground, this thing just like actually just came in and did it gently. Everybody's excited, woo! Because you just landed a rocket on
Yeah.
your second attempt to try to do that. So congratulations to Blue Origin. You know, we kind of were joking that in baseball, when you go from AAA to the majors, you're joining the show. So Blue Origin, welcome to the show.
Cool.
And it's very exciting to now have a company that is going to be reusing their rockets. And for
Yeah.
Flight 3, they've said they're going to take that booster and fly it again and see what happens.
Wow.
So,
Amazing.
Yeah.
Super great stuff.
So that's confidence.
Yeah.
So,
Cheers to Blue Origin,
Yeah.
and thank you for that,
Thank
Jared.
you.
Wonderful,
Thank you.
wonderful report.
yeah.
Well, Ginger,
Alright, yeah.
we had some. There's one
Who has
there
the
for you
phone?
if you want.
Perfect.
Here.
One of these. Okay. All right. So yeah, we have some pretty pictures for this month. Starting off with this one right here. I chose this one as the first one because of all the colors and lights and prettiness. So this is the first time that scientists have made a clear X-ray detection of chlorine and potassium in the wreckage of a star using data from the Japan-led X-ray imaging and spectroscopy mission spacecraft. Hopefully I said all that right.
So cool.
And so this is located about 11,000 light years away in the northern constellation of Cassiopeia. And yeah, I think it spans about 10 light years across. It's about 340 years old, so pretty
It's a
neat.
young one.
Yeah.
Super
Yeah.
young.
Right.
I like the young ones.
And then this next one, this is a pair of galactic cornucopia by Webb and Chandra, NGC 2027 or 2207. And IC, I'm not even going to say all the numbers because it's a lot. We don't need to get into that.
No,
No, we're not great at
astronomy.
naming things.
they're catalog numbers.
They're catalog
Yeah, they're just
numbers.
catalog
Yeah.
numbers.
But I did look into cornucopia is a horn-shaped basket. And so
Yes.
it traditionally carries fruits and vegetables, and so you can kind of see that shape there. In
Maybe
that.
there's alien fruit somewhere in there.
I'd eat
Yeah,
it.
maybe.
Well, yeah, it's like the big space cornucopia from the original Star Trek.
That's
flies
right.
Yeah. Tasty.
Yeah. And then we have this is the rare gourd. This was released December 12th. This is called the Calabash Nebula, also known as the Rotten Egg Nebula. You may have seen this pop up in your memes somewhere.
Yeah.
I know I've seen this one before pop up in my memes. And this resemblance is, as I said, the Calabash gourd. This is in the constellation Puppis, 5,000 light years away. And it is a protoplanetary nebula. So
Wow.
as you can see,
That's
those
amazing.
outer
Very
layers
cool.
ejecting. It's pretty interesting. And then we have this next one. This is Hubble serves up a holiday snow angel. So you can kind of see the wings.
Aw.
Pretty interesting. This is in the constellation Cygnus.
Is it wrong that I see a big evil face in that picture?
Oh, like the eyes.
Psychological
Yeah.
test,
Yeah.
Bill.
Yeah.
I see the snow angel, like the wings. And then
Sure.
the stars.
Yeah.
I see a casserole. It might just be food, though.
Well, we were talking about fruits and vegetables. So
Yeah,
that
I
makes
might be
sense.
hungry.
Stay
Yes.
in theme, guys.
So,
All right, this next one, this is the Necklace Nebula. I really love this one. Planetary nebula located about 15,000 light years away in the constellation Sagitta, the Arrow. And I had to look that one up because I wasn't
Very
familiar.
small, yeah.
Southern.
It's right in the Milky Way, if I remember.
Oh,
It's somewhere
okay.
kind of in the center near the Summer Triangle.
Right, yeah. So yeah, this is a pretty neat one. Love the shape there that you can see, like the diamond shape, kind of.
Very cool.
And then, of course, the Christmas Tree Nebula. Had to throw this one out in here, of course. This is located in the constellation Mostest, the Unicorn. It is about 2,500 light years away, and it's visible, actually, in the dark skies if you have binoculars, or a small telescope you can take a look through. And here is one with the Christmas lights on it, a little
NASA
GIF
made a
that we...
Oh, nice.
thinking,
Yeah.
That's what,
that's
that's
very
a
nice.
Chandra image that they had.
Yeah, they've added
It
the
is,
Chandra.
Yeah, yeah, so that's fun.
Set it
You
for
just took a
music.
picture of a star cluster and morphed it back and forth. Is that?
Right, yeah.
It's a little too big to fit inside a home, but
Yeah.
It's still little, but it's pretty.
little.
Is this what it actually looks like from Black Friday to New Year's?
Prices are reduced.
Oh, okay. Gotcha.
Okay, and then I love this image. The sprites over, how do you pronounce this?
The Chateau de Benac.
There we go. And this was taken on, thank you for that, December 9th, and the sprites occur at some 50 miles, so very high above, just very beautiful. And then we have a waxing gibbous moon. I think this is from the International Space Station, located 263 miles above the Atlantic Ocean, so pretty neat. And then, of course, I had to throw this one in.
Natural
Actually,
clouds.
yes, it's so pretty.
Is that
Above
air? I
clouds.
guess that's air glow, probably. That green and kind of reddish that's there.
Yeah, that's what I was going to ask you about.
Yeah,
It
that's
looks like
airglow.
an
That's
airglow.
airglow.
Yeah.
Air glow, by the way, is particles in the upper atmosphere retain a little bit of solar energy that they will release at night, and sometimes people mistake them for aurora. So they have a similar kind of color sometimes.
Then this next one is, of course, here at Griffith Observatory. This was taken by David Pinsky
Thank you,
during
David.
sunset. Just a gorgeous view. Thank you.
Nice shot.
Beautiful.
And the Geminids, I got this from Paul Smith Photography. He sent
Whoa.
this over. So very
Right through
cool.
Orion.
Rare
Right
to
through
see
Orion.
red. They're usually green.
Almost hit his
Yeah.
sword.
Would that be an Orionid? I think I asked this before. and I
It's
don't
a
remember.
it's a
Yeah.
Geminid.
It's a Geminid.
It's the
just
Gemini.
happens to be
Geminids that
going
are
through
crossing
Orion.
through.
So I think the peak was around the 13th
The
or the
13th.
14th.
13th to 14th.
Yeah.
Yeah.
Did anybody in here happen to see?
See
It was a
any-
very good year, apparently, for Gemini.
Oh,
It was
Oh,
a good
okay.
year and it was warm
So-
and I stayed home.
Apparently
too.
very
I know. I
visible,
mean, I wanted to go out and I
they're
just
very
did.
visible, the Grand Canyon.
Just did.
When was that meteor?
The Geminids peaked on the around the
I
13th or 14th.
think that one was on the night of the 13th.
Yep.
I think.
Yes, yeah, it was the
Yeah, 'cause
13th, I
I saw
think.
something very similar to that near
Oh, neat.
near Orion,
Nice.
outside my house in Temecula. So
Maybe that
Yeah.
one.
that it could have been that one.
Definitely.
Yeah, maybe.
All right, and then this one's very special, 3i Atlas. You took this one.
Yeah, so I shot this from. If you join the Los Angeles Astronomical Society, I'm not influencing, but you get to have access to this amazing dark sky site that is north of Los Angeles. So we went out there about 2 weeks ago. I was able to shoot this with this amazing Vespera 2 by Veonis, and I had to do this in a manual mode to be able to. So this is the interstellar comet is very far away and it's quite dim. So we did find it through a large telescope. And I do want to warn people because there's a lot of things going around right now. Oh, come to this thing, pay this hotel, and you'll be able to, we'll show you 3i Atlas in a telescope. But then you contact them and it's kind of unclear what kind of telescopes they have, or even people who might come to the observatory because it said it's closest to the Earth tomorrow and they think we're going to look at it. The telescope that I was able to see it through, and it was really a smudge. It was special because I work on it with Bryce, but it was a smudge and it was a 22-inch telescope, right? So a very large telescope. It took us a while to find it. Actually, this image I was able to, with this telescope, I was able to find the star field, an image. This is about 300 images that are stacked. I can't remember how many. They're about 10 seconds each. So, in order to get, again, that little level of detail, so be aware of those things going around. But if you have access to a very large telescope and a dark sky, by all means, this is now or never that you can actually see an interstellar object through a telescope. Highly recommend you go do that. So thank you for the parentheses.
Another thing I want to bring up here about this is there's still a lot of misinformation about this object out there. There's people that are quoting results that were from October. They're not looking at any of the recent papers. So if you really want to know about it, watch last month's show. We had Bryce Bolin, Dr. Bolin here, and it was terrific to hear from an expert that's taken these images.
He's here tonight
I think
somewhere.
he might be here. Maybe
Bryce?
we'll see. Bryce, yeah, there you are.
Yay.
Yeah, terrific. Thank you, Bryce. But
Bryce was here when
Very cool.
Bryce was with me when I shot this and helped us find it. And
And it's not
So it's
always
a-
a glamorous. I mean, you were out there.
we were out there and it was
Very
cold,
early,
and but that's
cold
astronomy.
and dark. But anyway, so you know, you can call up Griffith Observatory. We have a phone line you can call, talk to our museum guides, ask them about the latest results of it.
Yeah.
It's a very, very interesting object, and the story is much richer than these misinterpretations
Headlines,
and headlines.
Yeah.
It's a fascinating object, and it's really neat what's being done.
Can I also add it? I think you said now or never for this particular object, but we've reported on like 3 of these so far, obviously, because that's how
this
many
is
there
the
have been
third.
since
Yeah.
we began to be able to detect them and find them with instrumentation. And so now, I mean, you know, we might see 100 in the next few years.
But we may find none. I mean, the
Well, that's
prediction.
true. No, I wouldn't say 100.
Yeah,
That's
it's
true.
not. It's not going to be 100. The prediction
Yeah.
is about maybe 1 a year.
Okay.
I think that was what Bryce had told me. Vera Rubin will find about 1 or 2 a year, maybe.
Okay.
But again, we don't know because we found the first in 2017, Oumuamua, and then 2I Borisov was in 2019. And then we didn't have any until then. And these were
Yeah,
found
that's
kind of by somewhat, not by accident. Larry Deneau, does this amazing work. But we might not have one for another 5 years. We might
No,
not
that's
have one
true,
for
that's
another
true.
10 years.
Yeah.
Just to note on that, if you do take any pictures of the night sky or you're an astrophotographer, send your images to
Yeah.
us. We're happy to share them and put
Please.
them into our
Yep.
show. So
Get in touch.
this one, okay. So I was looking at the celostat here on the floor at the observatory, and just regular day, looking at the sunspots.
I love that
don't
we
know
just
if
say
anyone-
this is just a regular
It's just-
day.
it's just
This
a
is
normal
an
day, looking
incredible
at the
image of the
celestine.
sun
And it's
that
an
you
incredible
can see
instrument
Yeah.
as well.
at Griffith
Visual.
Observatory. It's
Exactly.
The only
amazing.
place
It's-
where you get to see it in this way.
It's Thursday.
But just a typical day.
And also we're at solar maximum, so
Yeah.
we're just
Right.
on
There's
the
a
end.
lot of sunspots.
Yeah.
Those are bigger than the Earth.
Very
those
large.
stars.
Yeah.
yeah.
They're ginormous.
Yeah, so I was looking closely. I don't know if anybody else sees it. I'm going to go just take a second to look at this.
This is another psychological test.
Does anybody else see it? The snowman, right?
I saw
Yeah.
it when you
Does
first
everybody
sent
else
it
see
to
it?
me, and I
Okay,
don't see it
I'm going to go
anymore.
back. So here's the one without it. And then here's the one with the snowman next to it.
See
All right. No,
It
that's,
looks like a
yeah.
screaming,
I see,
screaming
like,
out.
Yeah.
Right?
a watermelon.
No, that's not what I saw, though.
Oh, yeah,
This
so
is
let's
what I
go.
saw.
Yeah.
That I see.
So I don't know. Dog owners
Yeah.
versus. They both
There's
work.
There's two
I see
different
a
ones.
It's an
screaming
alien.
child's head sort of to the left.
Spend too much
Oh,
time
I
at the
didn't have that
observatory
one.
bill.
All right. So now I also asked
Yeah.
Ginger to pick out some of the prettiest pics that we'd shown all year long. So I cut them down a little bit because
It was hard
you
to
get one
choose.
every
There's
month,
so
and I
many.
thought there's just so many of them.
Yeah.
But this was a gorgeous one from February.
Yeah, I love
Oh.
this one. Westerland 1. So this is, located in the Milky Way galaxy, 12,000 light years away. And this was James Webb. I think we had this in our February show as well. So that's why I chose it.
Yeah.
It's just a phenomenal picture.
And then June.
Vera Rubin.
June, of
Very
course,
good.
had to
Of
do
course,
that.
terrific.
That was like the big highlight of that month.
Yep.
And then going forward, we have the Rosette Nebula. I love this image. And this was in Chile as well.
It was
So-
shot from Chile. Yeah,
yeah.
I forget what constellation it's in. Is it also in Vela or in Puppis, or-
Monoceros, I think.
Monoceros,
Yeah,
yeah.
Monoceros,
Unicorn.
5,000 light years away. So really, it's also a great amateur astrophotographer target. So
Yeah.
one of my favorites. It's pretty easy. And then October, this was the star-forming cloud in the Milky Way, Sagittarius B2. So good colors for October as well. Black,
Yeah.
orange.
beautiful.
And then of course, David Pinsky. We
Yeah.
have the
shot.
lunar
Beautiful
eclipse
shot.
taken on March 13th.
Which we
And-
celebrated the observatory. We had a wonderful event. It was really good times.
Yeah,
Yeah.
we had a great stream, and we chased the dragon away.
That's right.
That's right, yeah. Ella.
There's a lunar eclipse next year as well. I forget what time of year, but there's going to be another one. But it's closer to the middle of the night. I don't know if we're doing anything
We
here for
will.
that. But
I feel like
Definitely.
that dragon may come back. I don't know.
I
we'll
think
do a
it's
Come
stream
back.
at the very least. Yeah, March again. Yep.
And then November, this was the highlight for this month. This was taken by Todd, and this is Comet Lemon. So
It's one of our
great.
telescope operators.
Yeah. And we
And
don't
then-
just feature employees of the observatory, but we get images from them. So again, this is a call to all of you out there. Send in your images, and you could be up on the screen next
Yeah.
year.
Yeah, email us
Absolutely.
your images. We'd
Yeah.
love to share them. So,
And
then,
3i,
of
of
course,
course.
this one reappears because
you.
it was my favorite for
This
December.
is just
so.
terrific.
Yeah, thank you.
Now, we do have a Mostest for tonight. The Mostest. We just thought it was funny because every month there's another biggest,
Record.
furthest, brightest record. And I always was like, oh, come on, why do we have to do this? But it's kind of fun to go and look for what was the record that was broken this month. And this month, it is a supernova that exploded when the universe was only 730 million years old. The Webb telescope picked this up. It was picked up in near-infrared images, of course. It was also detected as a gamma ray burst. So that little red dot you're seeing there is the light from the galaxy that's down there. But this thing is, the universe was only 730 million years old. I think it's a redshift of 14 and something.
And it's before cosmic noon as well. Cosmic noon
Yeah.
is this period of time around 2-3 billion years where the universe was really, we had all these super luminous supernova and all these really bright stars forming. So it's pretty remarkable how early, and also apparently it's very similar to nearby supernova that we've been able to observe, and that's what's really
Yeah.
incredible.
It was a supermassive star that got to the end of its life and
Yeah.
blew up. So pretty cool. It was the furthest supernova we've ever detected. Now we decided, in honor of our Unwrapping 2025, we'd do the Mostest, of course. And we actually have 4 of them here. We had
And
Well,
we're involving the
we're involving
audience.
you here. Yeah, we want you to
okay.
pick which of these you think is the Mostest. So the furthest galaxy known, that was picked up by the James Webb Space Telescope. Or
This remarkable instrument that I spoke about earlier, the on the Solar Telescope, providing incredible resolution. You should definitely vote for that one. Just saying.
yeah. Or there was
Not influencing the vote.
There was the strongest hurricane with the strongest winds ever picked up that we talked about.
Yep.
Or the loudest gravitational wave that was picked up by LIGO, that was a merger
Amazing,
of 2
yeah.
giant ones. And it was the cleanest signal they'd picked up yet, and they were able to verify a prediction of Stephen Hawking that the surface area of these black holes wouldn't change. So verification.
So do we get
So
the
folks,
audience?
let's see what you think. Do you
So,
think
okay,
it's
who wants the farthest galaxy?
farthest galaxy? Raise your hands.
Got a couple.
There we go.
Okay.
We could
Who
do
wants
it.
who wants the solar one? That's it.
Oh,
That's it.
it's a little more. Yeah. All right. Anybody want the strongest hurricane? Wait, you're not for destruction? Okay, a couple people are. a couple people are climate change. The loudest gravitational wave.
Oh, that sounds
Oh,
so punk
that's
rock.
it.
It
I
got
think
more
it's a winner.
airtime. I feel like it got more
It got
airtime
more
in the
airtime.
explanation. It's really
well,
unfair.
so we're going to award the Mostest to the loudest gravitational wave yet detected by LIGO. So
Congratulations, LIGO.
Now, this year was also Griffith Observatory's 90th anniversary, and most shows we managed to put something into the show to celebrate it. And tonight we're celebrating a couple of things. The most successful thing I think we did this year for the 90th were these
Incredible.
passports that were created. They were available during busy times, certainly holidays and during the summer. Kids and adults came in, and you could go around the building, do the activities, collect the stamps. It was a lot of fun. We're going to have these for folks during the holidays again.
And they run out sometimes,
They run
so,
out.
you
So if you
know.
come up
Yep.
during the
Very
holidays and are,
popular.
where are they?
Collector's
Maybe we
item.
ran out. But
Collector's item, yeah.
they were amazing. And congratulations to all the folks that helped create
Yeah,
those
it's
for the
really amazing.
observatory. It was just wonderful. And then also, this little short movie was created, a little film clip. It's a few minutes long, highlighting the things we accomplish here at Griffith Observatory. So we're going to show this to you as part of our 90th celebration. So I hope you enjoy this.
Woo!
Nice.
And I want to take the time to thank Griffith Observatory Foundation, as was done there. They're our exclusive nonprofit partner of Griffith Observatory, and so much of what we do is made both possible and better because of their ability to contribute and help us. And that the thanks go out to everybody that makes donations, and also all the members of the foundation. So if you like what we do here at Griffith Observatory, I really recommend you go to the website, sign up and get the newsletter. That part's free. If you're excited about it, become a member. If you want to help support our programming, make a donation. There's even a donation button right on the YouTube stream. And you know I don't make pleas like this usually, but we really do appreciate our foundation, and they appreciate Griffith Observatory and what we're able to do. So thank you, everybody.
Yeah.
We're going to finish tonight's show with a little ASC Wrapped section where we look at the statistics and things we did here at here at ASC, All Space Considered. It was a year of change. We got some new light projectors behind us, and we got an Earth rug.
Look at our rug.
We're going to make some changes to the monitors in front of us. So, folks on the YouTube, you'll be able to see the rug a little better.
We got the whole world on the floor.
We really
No
do.
Europe, no Asia.
No flat Earth jokes.
Seriously?
We had some other additions too. Ginger, you joined the
Way
crew.
better than
Yay.
I appreciate that.
We showcased 10 special segments. Everything from
Time travel.
eclipsing, time travel, exactly. We performed Blue Skies.
That's
we had our
right,
crew
Ginger
here
and I,
perform
yeah.
Blue Skies
Bill.
live. We celebrated Black Space Week. We did Women in Space Week as well, and the Women of Griffith Observatory. So, yeah, thank you.
Going on. Yep.
A lot going on. Also, we heard Laura May light up about the sun
I'm sorry.
12 times.
I'm not sorry.
We heard it tonight a couple of times as well.
I'll try to do better next year, I promise.
Yes.
You mean 14 or 15?
14 or 15
Close.
times, yeah. It was also the year of the guest. Look at all these guests.
We had
that
a Nobel
had.
winner.
Nobel
Yeah.
winner to start. And by the way,
That was
you had to
amazing.
come in person for that show. You can't
Very
find that one
exclusive.
streaming. So,
Oh.
congrats to everybody that made it here. But we had a lot of great guests, and we'll have more coming up next year, of course. We asked the guides what was up in 2025 and what
That's right.
they were being questioned about.
Or that was more what they thought. So the previous one was what they were being questioned about.
Oh, right, yeah.
This survey was specifically what they thought was the most impactful, most important. Of course, Comet 3i Atlas, the biosignature on Mars, which did not get as much press and is so important. The Vera Rubin. And it was fun because we got to really see the division between, some guides studied dark matter, and there were some guides who were more planetary. And so we really saw this division between some of our colleagues who highlighted.
And was that you, Jared, with the Starship launches?
Actually, it wasn't.
It wasn't.
It wasn't.
It wasn't. Okay.
But
Not quite.
we said that would make Jared happy.
Yeah.
Inevitably,
I'll take
we
that.
did also have to mention, the second biggest answer next to Comet 3i Atlas was the cuts to science. So the current, in fact, this was announced this week, the closure of NCAR. This is the National Center for Atmospheric Research. This, by the way, the center actually contributes a lot to aviation. So aviation safety, turbulence, things like that. Major institution.
Well, one thing I worry about are things like solar storms hitting.
Yep,
Everybody
space
heard
weather.
about all
Yep.
those Airbuses they had to ground.
Yeah.
Well, if we
Yeah.
have predictions that space weather is going to hit, we can be prepared for things like that. So cuts to science is super, super important. In fact, I don't think the full NASA budget is out, the federal budget of what's going to be happening. Like, there's still
Yeah.
great uncertainty
Yeah.
about NASA programs and NASA funding and missions and people whose jobs rely on this. It's really difficult to plan your science when you don't know if your mission's going to be flying. It's really problematic. I mean, the Nancy Grace Roman telescope, it was a gift from essentially the NSA, the spy people gave the astronomers a spy telescope.
Hey, we got two spare
We pointed it up
telescopes.
instead of pointing
That's
it
right,
down.
yeah.
It's ready to fly. It got finished this month.
Yep.
It's done, ready to
Yeah.
go. They're not sure they're going to fund to fly the mission. So it's just crazy to have a telescope ready to go.
Also all the Mars samples. So the rovers have been
Yep.
collecting little samples on Mars,
Oh.
dropping them. And there was a whole plan to go pick them up, and that is canceled in the next budget,
Yeah.
as well as this mission to Venus.
Yep.
There's overall about a 50% reduction in the NSF funding and about a 47% cut to the NASA budget. So it's not surprising that it's on people's mind.
It's on
I think.
people's minds.
Yep.
Well, our final little pick, we decided we'd each pick a story, and I decided my favorite was that biosignature, the leopard spotted rocks on Mars that
Amazing.
could be from biology. We could be seeing signs, and there's a sample of that waiting to be picked up.
Yeah.
What was yours, Laura May?
Unsurprisingly, predicting the solar flares. This was actually one of the, this was a double AES. So we will cover in February our Super Bowl of Astronomy. We'll be going there next month. This is the major conference where all this new research is unveiled. And so last year, Emily Mason and other collaborators at Predictive Science actually released this really, really incredible research on how to predict solar flares, which we all want to do. That's kind of a holy grail, by analyzing flickering of UV emissions in these little coronal loops that are right above, that are close to solar flares. So they analyzed that, and they found that for a couple hours before solar flares, there is a flickering of extreme ultraviolet light. So really, really remarkable results. And again, this is really groundbreaking research that really affects our technology and our way of life. And
In fact, I think we have some separate slides for these. So let me forward to them. In fact,
Sorry,
Daniel,
I just got
oh no,
too
that's fine.
excited about
Well,
this.
you get excited about it. But Daniel Perea, one of our producers, he's hosting our YouTube stream as well. Hi, Daniel, you're out there, and
up,
hopefully you
Daniel?
didn't have to ban too many people tonight. But say hi to the chat for us, of course. Hi, chat. We can say hello. They're watching us. What am I
That's
saying? He picked the surprising dark sides of Uranus's moons, and we had him record his little reason behind it and why that was his favorite story. So let's take a look. Let's listen to Daniel remotely.
Back during our AAS 246 segment in July, we covered how a research team from the Space Telescope Science Institute used NASA's Hubble Space Telescope to study the 4 largest moons of Uranus. The research team thought they would see particles carried by Uranus's extreme magnetosphere darken the sides of moons that were facing away from Uranus. But instead, they found no evidence for darkening on the moon's trailing sides, and actually found clear evidence for the darkening of the leading sides of the outer moons. I personally love this story because it reminds us that we can still be surprised by planetary mechanisms, even in our own cosmic neighborhood. I especially love that this is also a Uranus story, because the 2022 Planetary Science and Astrobiology Decadal Survey listed launching an orbiter/probe mission to Uranus within the next decade to be the highest priority mission for space agencies across the world. This finding only solidifies that recommendation.
Yeah, totally agree with Daniel. It'd be great to send a spacecraft there. Now, Jared, you thought the New Glenn landing was one of the most important stories.
Yeah, looking at the aerospace world, Blue Origin coming onto the scene has kind of been a welcome, refreshing burst of competition to finally arrive here, at least in the United States. So we're all very much looking forward to seeing what Blue Origin is going to be able to accomplish with their orbital class rocket, New Glenn. Being able to see it land on the second attempt was one of the wildest things I think I've ever seen in at least the 2020s, simply because, yes, we've seen the rockets come down and land nice and gentle, but we've never seen a huge 200-foot tall booster just sit there for a couple seconds and then decide, I'm going to slowly drift down.
Yeah.
Like it decided
That's
to.
pretty crazy.
It was a smooth operator, and I got to say that is nice to see that. And I just cannot wait to see what this next year and what the years coming up are going to do now that SpaceX has competition. It's only going to make it better for everybody. So.
Now, Bill, you thought the icy organics ejected from Enceladus were
Yeah, I'm a
was an
big
important story.
life and space guy. I want them to find life in space in my lifetime. It's a bucket list thing I have no control over whatsoever. But this is one of the prime candidates. This is, if you've been with us a long time, you remember when we covered Cassini mission, which went to Saturn and some of its moons. And this is one of its moons. They were surprised to find geysers shooting out of the South Pole. They flew through some of the geysers. This particular story actually, you know, it's about a mission that ended in 2017, and data I think was taken in 2008, and we're, you know, talking about it in 2025, because they found new organics, more complex, more interesting than they've ever found before. And the way that they actually did it was they flew so close to the surface. You know, if you fly up here and you get those, you know, ice bits up there, they've been out there a while. They maybe days, weeks, months. And solar, radiation does, you know, affect them and change the composition sometimes. These were really pristine. They were like days old data or stuff. And this, so the mission would, you know, had an onboard spectroscopic analyzer that would analyze the stuff and then send the data back instead of coming all the way back with samples. Anyway, this is a very promising thing. And you know, for life, you need three things. You need an energy source, which is generally heat. You need liquid water, and you need complex organics. This place has all of them inside. It's under its icy shell. They're very. It's a very high probability that there's a liquid water ocean underneath there. So.
Let's go.
Wow. I know.
Wait
That's
for
the
it.
next go.
We all send $10. They'll launch it. You know.
So you send us $5, right?
$5. So now, Ginger, you picked the Vera Rubin image release.
Yeah, these were all just amazing. I mean, just incredible victory here for imaging and astronomy. I mean, all the discoveries, how many pictures of galaxies and asteroids. Just, it was an absolutely
It's going to find
incredible.
a lot of asteroids, a lot of objects.
Yeah.
We did
And
learn again.
fast.
Tune into last month's show that it's not necessarily well tuned to find all of those small bodies, though. So you got to go watch last month's show if you want to find out about that. And then this is what you were talking about.
Sorry,
about the-
I got ahead of myself.
Well,
But you know, these are those little coronal loops, these little structures that I was talking about, just above the solar surface that were next to some of these solar flares that were happening. So they looked at about 50 of them, and yeah, saw that little UV flickering. So maybe someday we'll be predicting solar flares a couple hours prior, or the strong ones at least. So that'll be exciting.
This was my pick, the leopard spotted rocks. As you can see there, there's a circle that says leopard spot. It's white in the middle, has sort of a turquoisey, grayish color around it, and then the reddish color is the iron-rich, hematite-rich soil, or the part of the rock. Well, those little spots probably appeared as microbes were using the energy that's locked up in that rock. We see this on Earth rocks,
amazing.
where microbes were using the energy from this. So maybe olivine has nothing to do with it, other than that was carried down there. They were kind of curious how the olivine got there. But this is a weird rock, and there's a sample waiting for labs on Earth that could disentangle this, that could look for further evidence and verify, is this biological, is it not biological? We don't have any good non-biological ways to explain this, by the way. They all require really high temperatures, and there's no sign this rock was under those sorts of temperatures. So we don't know. Kind of cool. Now, so that was our top 6, but you know, we don't just have 6. We have a 7th.
No.
Yeah, I know. I had to do it. We have to make it uncool because it needs to go away. So our 7th story is actually the Euclid image release. There's this wonderful telescope, Euclid telescope, run by the European Observatory, and it's just crazy. It has taken a huge chunk of the sky. It's seeing thousands and thousands of galaxies. It's just, the data is incredibly rich from this telescope. In fact, we had it in a show, and we didn't have time to cover it, and we never went back to it. So we're going to have to find somebody from the Euclid mission, maybe to join us in person. If we could get a guest from it, it would be that important, because it was that important.
And it's a dark matter and dark energy mission as well. So it's a very important cosmology mission that doesn't get spoken about as much because the images are not always as sexy as some of the other telescopes, but incredible work that they're doing.
Incredible work they're doing, and there's some great image releases, fly-through movies, things like that. So those are our top 7 of the year, our favorites. They aren't necessarily the biggest science. Maybe there's some other ones that you like out there. Well, write to us if you think we didn't get your favorite show out there, and let us know what you think. But next month, we've got a great couple of guests. We're going to celebrate 100 years of the Los Angeles Astronomical Society with the president. President Keith
Got a couple
Armstrong.
members here tonight.
Great group.
And President Emeritus Tim Thompson is also going to join us. So we'll have a couple of fantastic guests to talk about what has the LAAS done for us. And I thought they were older than that. We'll dig into that a little bit.
We are older than
Yeah.
the observatory, though. 90 years this year of Griffith Observatory, 100 of Los Angeles Astronomical
Yeah.
Society. So
We'll catch up.
Yeah, so come on up to the observatory, join us in person.
it's very ominous.
We're
you can
halfway
join-
there.
You can join the fun in the audience, or watch us on YouTube, of course, everybody. And like always, All Space Considered is brought to you by Griffith Observatory and the Department of Recreation and Parks in the city of Los Angeles. And again, I want to thank Griffith Observatory Foundation, our exclusive nonprofit partner. And thanks to all of you for the wonderful year we've had. It takes all the support from the public for us to do what we do. So thank you, everybody. And
Thank you.
thanks, Griff.
Thank you.
Thank you, guys.